Hello students, this is Mrs. Farragon. In today's lesson, we're going to be talking about lines, angles, and triangles. You will be able to apply your knowledge of geometric concepts to identify lines, line segments, rays, and angles. Let's begin with a point. A point is an exact location on a plane surface, usually represented by a dot. We're going to label it A. To read this point, we would read it as point A, and to write it, we would write the word point and then put the letter A. A line is a set of points that forms a straight path extending in both directions without end. We use arrows on both sides to represent that the line is infinite. So we're going to call this line BC. When we read it as line BC or line CB. When we write it, we place the line symbol above the letters BC or the line symbol above these two letters CB. A line segment is a part of a line between two endpoints. So here is a line and then you have two endpoints on each side. We're going to label these endpoints DE. When we read it, we can read it as line segment DE or line segment ED. We write it with the line segment symbol above the letters DE or above the ED. Array is a line that has one endpoint and extends in the other direction without end. So with the ray, we have an endpoint, and on the other side, we use an arrow to represent that this ray goes on forever. When we read it, we begin with the first letter of the endpoint, C. So we start with this letter first. So when we read it, we would say ray CD. We write it as CD with the ray symbol above the letters. Intersecting lines. Intersecting lines are lines that cross at one point. So for example, we take these two lines and we have them intersect here at this endpoint or point, Z. We know that this line here, let's call this line IK, and we can intersect it with this line called JL. And the way we read it is we say that line IK intersects line JL at point Z. We write it using symbols. So we say IK with the symbol, with the line symbol above it, and LJ with the line symbol above those letters intersect at point Z. Now we have special types of intersecting lines that are called perpendicular lines. They are two intersecting lines that cross and they form right angles. So let's take these two lines and cross them where they form right angles. So we're going to call this point L where they intersect, and the blue line we'll label it as DR, and the purple line we'll label it as EO. We can put a piece of paper to make sure that each quadrant makes a 90-degree angle. And if you notice here, all four quadrants had 90 degrees. They all formed right angles. And here you could even draw a little box or a square around to see that you have squares, which are your 90 degrees. So the way we read it as, we say line DR is perpendicular to line EO, and when we write it, we put the line symbol and then we put the letters DR is perpendicular, that's the symbol for perpendicular, to line EO. Now let's talk about parallel lines. Parallel are lines on the same plane that never intersect or cross. Think of it like parallels. So let's take this line, DN, and they will never cross this line JM. These are parallels, like a pair of L's. We read it as line DN is parallel to line JM. We write it as DH, the line symbol above, is parallel, that's the symbol for parallel, line JM. Now let's talk about angles. Angles are formed by two rays with a common endpoint. They both originate at the same endpoint. So if you take a ray and join it here at the vertex with another ray, they form an angle. So we can call this angle as angle SQT. We can also name it or read it as angle TQS or angle Q. When writing it, we put the angle symbol. Whether it was a right, acute, or obtuse, we would still use this as a symbol. Now, talking about a paper test, if you noticed here, if I use a piece of paper and I line it up to the corner, so here's the corner of the paper. If my angle goes inside the paper, we know that that's an acute angle. A right angle would outline the outside of the piece of paper, and the obtuse angle here, if you notice, your right angle would be where this pink and blue are, but please note that the blue line extends outside of the paper. So this is an obtuse. Now, acute angles, let's go more in depth with them. They measure less than 90 degrees. So if we were to draw it, we would take the ray, put our paper, remember, from corner, this corner, and this corner, create a 90-degree angle, which is a right angle. Now, an acute is less than 90 degrees, so that means the other ray would have to fall somewhere within this piece of paper. So let's go ahead and name this angle, and we can say SXG is an acute angle. Now let's talk about a right angle. A right angle measures 90 degrees. When we draw it, we start with the ray, and then we're going to put our piece of paper, and we're going to mark where the 90-degree angle is, and then we put our other ray. Here at the vertex, we're going to call it H, and then S and L. So we can say that angle SHL is a right angle. It makes that square corner. Now we have an obtuse angle. It measures more than 90 degrees and less than 180 degrees. So here's our ray, and we're going to use our paper and our angle measurement test. Here it's 90 degrees. Remember, it says an obtuse angle measures more than 90. So that means the other ray is going to have to extend past this pink line to become an obtuse angle. Here, the vertex, we're going to call it N, and the 2 points B and H. So we can say that angle B and H is an obtuse angle. We are now going to talk about triangles. The first one we're going to discuss is an acute triangle. It's a triangle with 3 acute angles. So let's take this angle and let's call it A. You can see that it forms an acute angle because it falls within the piece of paper. Now let's look at this angle here and call it B. If I was to put my piece of paper in the corner, I can see that it falls within the piece of paper, and angle B is also an acute angle. This angle C also falls between the piece of paper, so it's another acute angle. So we would read this as triangle ABC. There are other names that you can give it, just depending on which way you trace your triangle. But please remember, an acute triangle has 3 acute angles. When we write it, we take the letter and we put the symbol, the triangle symbol, in front of them. Now let's talk about a right triangle. A right triangle is a triangle with 1 right angle and 2 acute angles. So let's take our piece of paper to construct our right triangle. We know a right angle is a 90-degree angle, so it's going to go straight up and down. Let's call this angle A. It outlines that piece of paper here, which is a right angle. Now let's look at this angle here. We do the paper test for angle B, and you're going to see that it makes an acute angle. It falls within the piece of paper. And then C, angle C, is also an acute angle. So we will read this as triangle ABC. We write it as the symbol, using the symbol a triangle with ABC or the other letters, depending on which way you trace your triangle. Again, a right triangle is a triangle with 1 right. You cannot have another right on either side here on your angles because you cannot create a triangle. An obtuse triangle is a triangle with 1 obtuse angle and 2 acutes. So again, here's our paper, and this angle, we're going to call it A again. It extends outside of the piece of paper, so we know that that's an obtuse. Let's join our triangle. And on this corner here, this angle, it has an acute angle. Let's name it B. Then here, if we have the paper test again, we can see it forms another acute angle, and let's call it C. If I was to put this piece of paper on this side of my triangle, you can tell that this angle is still an acute. So when we read it, we say triangle ABC. You can also say triangle ACB, triangle BCA, and so on. When we write it, we just put the symbol in front. Again, an obtuse triangle has 1 obtuse side. The other 2 have to be acute, or else we cannot close our triangle. We have reached the end of the lesson, so have a great day. Bye.